In this lesson, I'm going to be showing you how we can create an animation, a couple of different planes flying around, and having the camera target specific planes and also change between different targets throughout time. We're going to be using Time Cycle and Time Morpher from snowFlaKe. So to start out with, we need some objects we can animate, and what we're going to do is load in a couple of the included plane objects with view. So under vehicles and aerial, we're going to load in just the first plane, the FW190A. And then also we're going to load in the P40C. Okay, so to reduce the amount of objects we have in the scene, what we can do is bake these objects, because at the moment they're all broken down into individual pieces. And if you want to animate individual pieces, then you wouldn't want to condense it all. But I'm just going to be working with these formed object groups. And to make things run a little quicker, I'm going to right-click with the object selected and go to Baked Polygons, click OK. And same thing with the other plane. Now, if you need to separate it, one thing you can do is split by material. So if you want to go back, you can split it. In this case, with the FW190A3, you can split it into 35 different objects based on the materials. We're going to go ahead and keep these as individual objects, and I'm going to add a new layer. And one more. We're going to separate, because we're going to have a group of planes. And what I want to do is take the P40C plane and copy and paste it to have another duplicate. We're going to have two. And what I want to do is group these together. And just for now, I'm going to go ahead and take the FW190A3, and we are going to just hide it. We could also just turn off the layer and hide the layer. So the first thing we want to do is set up a spacing for the objects between each other. So what we're going to do is take the individual objects and start working on a graph for each one and decide which way we want to offset them. So what we're going to do is take and add an input node external dependency and set that to the group position. Then what we're going to do is add in a combiner node, set it to add, and then we are going to just add a constant vector for the offset that we want, and we're going to be offsetting them on the Y. So that's going to be the middle, and let's go ahead and start with just 5. So our first connection is going to be the external dependent. And then we can connect to that constant. Actually, I am going to go ahead and, because we have a dynamic group, I am going to make that the second input and make the constant the first. So input 0 of the combiner is going to go to the constant and add for input 1 to that external dependency and connect our position to that. So now we have that offset. What we can do is go back into that graph, select all of these nodes, Control C to copy, go into the next object, Control V to paste, and if you are unable to copy and paste, in some cases certain nodes won't be allowed to do that. What you can do is create a MetaNode and save out the MetaNode as a temporary and then load it in. So to create a MetaNode, we could just select these objects, click Create MetaNode, and then go ahead and save that. So then when you want to load a MetaNode, you can right-click, load MetaNode, and then ungroup it within the other function. So what we want now is an opposite. So we're going to take that 5 and set it to -5. And now we have a bit of an offset here. We're going to go ahead and increase that. Those are a little too close. I'm going to change this to 10. And basically we're working with meters right now, so this is offsetting by 10 meters. So the distance between the two is going to be 20 meters. So now we have this group, separated planes, and our other plane in the center. And now we're going to make them go in different directions. So we are going to rotate the group, going to the numerics tab, going to orientation, and changing the yaw to 180. And maybe because in some cases when you have these dependents linked up to the graph, it won't necessarily work to modify the group. So what I'm going to have to do, because it does look like we've lost the ability to control the rotation with those other graphs set up, is we'll just go into the individual objects and change those, rotate them 180. Okay, so now we'll select the group, and what I'm going to do is take the position. So going to the numerics tab, and the first tab is position. We're going to change the Z, and let's go ahead and set it up to 700 meters. So we also want to take our camera and set it up to about 700. And then we can take our other object and go ahead and to the aspect tab, turn off hidden, and change its position to 700 to match it up. Then we're going to set our initial starting points for positions of everything in the scene. What we want to do is have, or I'm going to go ahead and take the camera and put it a little bit behind this middle plane. This is going to be our first target. We're going to be following it and having the camera with a matched speed. And then we're going to switch targets over to the two planes on the side once they pass by each other. So we do need to have a starting point for each object. We're going to go ahead and select the group, and we should be able to change the position on the X. So we'll go ahead and change that to 500 meters. Might not be enough. Let's go ahead and do 1100. And now we're going to take the other plane in the center plane, and we're going to move this one back. Let's do -300. So we also needed to take the camera, and -330 because we did have a bit of an offset. Okay, so let's start by just setting up the camera. If you're going to be using the camera controls on the right, if you hold down the control key, you can slow down the motion, or how sensitive the controls are. It does make it a little bit easier to control. So let's go ahead and take the main camera, and we're going to edit the object graph. Also, good idea to store the main camera, which will give you a new camera called camera 1, which is a duplicate. In case something happens to the main camera, sometimes if you disconnect a graph the wrong way, it can break the camera, as that does sometimes happen. And that's not really specific to any of the snowFlake tools. It just, whenever you have anything that's dynamic, if you remove certain connections, there's a tendency to create too large of an offset or too large of a vector, which just causes the camera to become almost null. So I'll show you a way you can avoid that once we get the setup complete. What we're going to do is first set up our orientation, which is going to be a target. What we're going to use is a dynamics node. So we're going to right click, go to add dynamics node and a track relationship. What we need is an external dependency, so add input external dependency and connect that to the object we're going to be following and set it to its position. So this is the FW190A3 position, and then that's going to connect to input 1. Input 0, the first input of the track relationship, will go to the object itself that we're controlling, so the position of the camera. And then we can connect orientation to that track relationship. And now we have a target on that object. So no matter where this object goes, the camera is going to follow it within the center, unless we set up a bit of a delay within it. And we'll take a look at that once we have our motion set up for the planes. And I'm just going to do one more thing really quick. I'm going to hide the ground from the render and add in just a water object, so the sea. So it's a little more interesting of a scene. And we can go ahead to the atmosphere editor, take the sun, and reposition it so that we're not looking directly at it. We could do more of a sunset, lower the pitch. That looks a little better. And I'm going to go ahead and just save it at this point. And then we'll start with the motion of the different airplanes. So I'm going to select the FW190A3 object that we are targeted on, and we're going to set up the motion for it. And what we're going to use is time cycle. Add input node, MetaNode, time cycle. Time cycle has a built-in time input, so you don't need to connect it to the input node of time. If you want to make any further adjustments before reaching time cycle, any changes to the time, you can use the time input up at the top and checking on use time input and connect that to time. And that way you can work outside of the node to manipulate time before it reaches the time cycle metanode. I'm going to go ahead and turn that off, and we're going to use the internal time, which is just a time integrated into the time cycle node. What we're going to do is define our motion per second. A cycle is going to be repeated within a loop, and a time cycle is going to be the length of time of each cycle. So if we set this to 1, our time cycle is 1 second. Distance is going to be our numeric output based on that time cycle. It is going to increase over time and keep adding to it. So this way we can set up a velocity for the speed of the plane. So if we go ahead and set this to 90, we're going to go 90 meters per second, which is roughly 200 miles per hour, or 300 feet per second. So what we want to do is our output is a numeric output, and we want to control the vector, the position. So what we need is math node, vector operations. and we're going to use the composer 3. And what this does is take x, y, and z numeric values and convert them into a vector x, y, z. So it's just a way of condensing 3 numeric inputs, x, y, z, and making them a vector output, which is the red link that contains the 3 numbers. So what we're going to be controlling, and we do need to set up our initial value as well. Adding in a constant node, setting it to a constant vector. This is going to be our starting position. And what we're going to do is add these together. So our starting position, if we take a look, because we have the object selected, we can go to the numerics tab, select position, and now take that information and put it into this constant node. So that way we're starting at the same spot we have the object right now. What we want to do is add in a combiner node, set it to add, and we're going to take this constant value and we're going to add in the composer 3, and we need to connect whatever we're going to be, or whichever distance we're going to be traveling by connecting the corresponding composer input. So we're going to be moving on the x, so we need to connect x to the cycle distance outputted by time cycle. You also have a couple other outputs. Cycles passed keeps track of how many cycles have gone on, because if a cycle is more than 1 second, that information can be rather useful for connecting other nodes. The cycle distance is the output of distance per cycle, and then time is the internal time modified, because it will repeat time if you have looping turned on. So we're going to select cycle distance for the x, and now we can connect our position to that add combiner. Okay, so what we're going to do is make sure loop playback is turned off. We're going to limit cycles, and once you limit the cycles, it's going to run through the exit spline. That allows you to run a certain amount of loops and then have it the motion continue on the exit spline to kind of ease the motion out. We want this to be linear, so we're going to go ahead and reset that filter. And now we can see the motion. So we're going to set up the same control for the camera. And really all we need to do is just take the entire setup here, copy it, Control C, go into the main camera, into the function or the graph, and we can paste in the value. We do need to change the constant vector to match where the current camera position is. So looking at the numerics tab, position -335.6, and we've got 9.4 on the Y and 696. We'll go ahead and round it up, 697 on the Z. So now we can connect our position to that same output. So we have the camera moving with the plane. And we might need to offset this a little further back. So what I'm going to do is go into the FW190A3, and we're going to offset the X to -800, which means we also need to go into our camera and change that 3 to an 8. And this will start us back a lot further. Okay, so these planes, the other two, are stationary at the moment, so we're going to set up the same motion for them. and we can do that with the group. So we're gonna, we should still have the time cycle in the memory, so we can paste it in, and we want to set our position to 1100 for the X. And what we're going to do is go into the time cycle node, and the distance, instead of going 90 on the X, we want to reverse that. So we're going to go negative 90. And that way we're traveling in the other direction. So if we take a look at this from our top view, we should be able to see those moving at 90 meters a second. Now we're also going to be making some changes to the orientation. Now at the moment, the pivot locations are not quite where they should be for the correct motion. So what we're going to do is go through each object, and I just went ahead and right-clicked to frame the selected object up at the top here. So select each object, and we're going to go to the numerics tab at the bottom, which is the pivot position, and we're going to click on this eye to show the pivot. And what we want to do is click on the pivot in the viewport and just drag it so it's just underneath the back of the wing on the bottom. We might bring it forward just a little. So this is going to be our point of rotation, which is basically going to be where the air and the wind that's being cut by the wings is starting to kind of push down off of that. So we're just going to set that up for each of the objects. So you will need to turn on the show pivot for each object. We can bring that down, go to the other object, show pivot, and move that to basically the same location. So now we can go to the objects and turn off the show pivot. It does look like this object is rotated, but just in the pivot. So what we need to do is modify our pivot. We can't change the orientation of the pivot, so what we can do is just change the Z orientation, or the yaw, in order to get it to be a little more straight. And just kind of remember that in case we start to control that within the function. So it is off a little bit by just a few degrees. Since I've already grouped the object, it's a little late, but before baking it, what I could have done was take the objects within it and rotate them first within the group, and then when I bake it, the pivot orientation would be locked and there would be no orientation showing, because right now we do have to offset it a little bit, not by much. So the next thing we're going to change is the orientation of the current target object, as the planes pass by and intersect with each other. So at around 10 seconds in or so, we want to have it kind of tilt sideways. So what we're going to do is be changing the pitch and changing the pitch orientation. What we can do is use time cycle, and we're going to copy and paste these two nodes, just using the same what we have for position, using time cycle on the X to modify the orientation. What we're going to do is change the cycle time to 3, We're going to set up our pre-delay to be, let's go ahead and start with 10 seconds. And we're going to limit cycles to 1 and also limit the time. This way, what's going to happen is we should bounce between 90 and then go back. So now we're going to connect the orientation to the time cycle. Looks like I do need to go in and make a change. Basically, we need to reset the time spline for the loop playback to the original state. Resetting it will not bring it back to the MetaNode default value, but you can just change it really easily. We're going to go to the upper clamping mode, set it to mirror, lower, we're going to set it to mirror, and then we're going to turn on curves to ease the motion in and out. So we're limiting it to 1 loop, so we're going to go to 90, and then we're going to go back and bounce back. So now it's just a matter of adjusting our start time. We'll need to bump back that delay. Let's go ahead and change the pre-delay to 9. If you want a longer time staying at 90, we can use spline B. And what we can do is add another point, kind of drag that out. So that's how the B-spline helps a lot, because that way we can have it ease into the motion 1 speed and then ease back at another speed. So that's the primary use of the B loop, because it is set up a little bit differently, where the first filter is going to mirror itself in order to create the loop. This one extends the time. It uses the full cycle, whereas the other one will cut it in half, but the amount of distance will be identical. Within the node, it does automatically compensate for whether or not you're using that spline B or not. If you want to set up an exit spline, I am going to load in the original time cycle exit spline copy and paste that in. Okay, so that's just kind of our main motion. We're going to be setting up a little bit of variance too, because right now the plane's flying very straight. I'm going to add a little bit of turbulence, but we're going to set up the motion for the other 2 planes as well. Rather than using time cycle for this, we're going to use time morpher. So what we're going to do is select the individual planes and go into their graph, and we're going to modify the orientation. So what we're going to do is add in a combiner node, MetaNodes, and time morpher auto additional. We can open this up, and there are a couple of different nodes in here. Time morpher is set up to control color, number, dual texture coordinates, or a vector. So we're going to use the vector connection. We can copy, Control C, click OK, and paste it in. If that isn't working for you, what you can do is ungroup the MetaNode, and then it'll give you all of those different nodes in there. To kind of reset the layout of the function. So I'm just going to reload it. Combiner, time morph for additional, copy the vector version, paste it in. So now time morpher does need to be connected to a time input node because of the way it passes information between nodes. The first time morpher of a chain always needs to be connected to time. Anyone following that needs to be connected to the previous time morpher node. So we'll take a look at that in a sec. Our pre-delay we're going to set up for 9 seconds. So 9 seconds into the animation, we're going to transition between the start vector and the end vector. With our yaw currently set to 180, we do need to have 180 set on the Z for both the start and the end, so that doesn't change. And we're going to change the transition to, let's go ahead and use 2 seconds to start with. And what we're going to do is change the pitch, or the X, to 90 at the end. So we're going to have it rotate 90 degrees. And then we also needed to rotate back. So we're going to copy and paste in time morpher. And we can delete that input connection to the top time. And we're going to take this time and output it to the previous morph. Also take the start and connect that to the vector output of the previous time morph. So that what that's going to do is once we reach the end, that's going to become the start of the next node, so we can make our changes. So our end is going to be 0. So that's going to return us back. We don't want a pre-delay, or at least we don't want a positive number. What we could do is change it to -0.5 or -1, and that's going to ease in the transition a little bit better because it's going to overlap the previous morph. That's if we want the rotation to be immediate after the initial rotation. If we do want to have a delay, we could enter that in. So first let's just take a look, setting our orientation. And that whips by the camera, turning in. If we want to take a look at this, go into the side view and just see what's going on with the motion. You can see it comes back very quickly. So if we did want to add a delay to that, we can go back into the graph, set the pre-delay to maybe 2. So that's going to offset the transition by 2 seconds. Maybe that's a bit much. So we'll just set that to 1. So just 1 second it's turned and back. And then if you did want to have it start to move off to the side, we could set that up as well with additional controllers, the same way we're controlling the distance traveled on the X. We're just going to look at simple motion right now, just taking this rotation and applying it to the other object within the group. So we're going to copy those 2 time morphers, go into the graph for the second object, paste it in. Now we need a reverse direction. So instead of 90, we do need to go backwards. So we do want to set this to 270, and we need to set the start to 360. Which means the end will also have to be 360. Because otherwise what we'll end up doing, if we leave that at 0, is it might do a complete turn or go 270. I'd rather have it go backwards, so that we're performing and having it change the pitch in the other direction. So we need to add in input node time, connect time morpher, and connect that to our orientation. So now we can see they split apart and go around each other. If we want to bring those a little further in, we can go back into these objects and change the distance maybe to 7.5 and negative 7.5. Now there is one easy way to make these start moving off into the y direction equally as they start to turn. And what we can do is set up a value that we can transfer between the nodes using external dependency. So we can use time morpher again for this. Copy the time morpher from the other side, paste it in. If you want it to be exact, you can actually use these time morphers to control the ratio and set up the connections manually using blenders, which is what it does on the inside of the node. And that's very similar to using the time morpher input node, which outputs a ratio and also time. With time morpher auto, the vector or whichever control you want to use is built in. So if we did want to use the ratio, and actually I'm just going to go ahead and delete the other time morpher because we can create a cleaner function that's going to allow us to run even more operators without slowing anything down. But this version does not have a ratio output because it makes it a quicker connection for chains to be able to take that time input and connect it to the output of time for the previous morph. So since there's only one connection, it automatically connects without having to choose between the time or the ratio. We're going to go ahead and open this up and output that ratio amount. So add an output, double output, and we're going to call it ratio. And then go into the next time morpher and set that up the same way. Add an output node, double output, and call it ratio. So this way what we can do is set up a manual blend between two constants. Take this constant and we can add in another constant node vector. And we're going to go from 7.5 and we're going to add in, let's go ahead and just double it. Now I actually do want to be able to just output this control directly to the other object without having to re-enter in all the nodes. So what we need in that case is an opposite, but that only works with numeric links. So we do need to have a composer, MetaNode vector operation composer 3. And we're going to be composing the y. So we're going to set up constant numbers. So we're going to set up 7.5 and set up another constant 15. So before we reach the composer, we need to just control the ratio of the numbers. We don't need to control a vector. And because we have the output of a ratio, we don't need to worry about the fact that this one's controlling vectors at the moment. So what we can do is add in a combiner node, set it to blender, clip ratio 0 to 1, take the ratio, output it on the side, and if you don't have these links showing on the side, turn on the show parameter connections, and that will add the links. Sometimes you need to move a node around in order for all the links to show up to get them to refresh. So we'll just connect that to the ratio, the first 0 to the 7.5, input 1 to the 15, connect that to the Y. And this is going to be our vector that we're going to add. So we're going to replace that constant with this new one. Right now, so we just have it moving off to the side. We may not need any additional usage from the other time morpher ratio, but in case we want to have it kind of sway back and forth, we can use the other one. So what I need to do now is add an output custom dependency, and we're going to go ahead and set up the opposite node in here. Add a filter, set it to opposite. It's going to create the negative value. Our custom dependency is going to be the Y position offset. I'm going to go ahead and throw some brackets in so I know it's a custom dependency. Click OK. Go into our other plane and go into the graph, and we're going to be replacing this node with add input node external dependency and choosing from the other object the Y position offset. Add in a MetaNode composer. Connect the Y to that external dependency and just replace the link. So now they're controlled with that same output, and once the ratio kicks in from the time morpher, it's going to control the separation and Y position. So we should see them move off to the side a bit as they start to turn. And then they turn back, and if we kind of want to have them wobble in and out, we could add some delays, but for now the motion is working because I'm still going to be adding a bit of turbulence. I do want to change that motion value. I don't want to double. So we're going to go back to the host object that has the custom dependency, and we can change that 15 to say 10. And that's not going to automatically update both of them, so that way they're not traveling so far. I do want to make sure that we have our motions easing in and out. So I'm going to go just into the time cycle for the other object. And just changing the orientation. And that should help a bit. Before we modify the planes anymore, I want to set up the target changes for the camera. So we're going to go to the main camera, and what we want to do is pick when we're going to switch the targeting mode from the current target, the FW190A3, over to the group of the planes that are coming towards us. So it looks like around maybe 10 seconds or so we should start the transition. So what we can do is go into the main camera, and we're going to modify our track relationship. What we're going to do is add in input node time, because we will need that for the time morpher. Whether or not you want to set this up manually with blenders, or use the auto addition that has the setup vectors, really depends on how many different time morphers you're running in the scene. If you've got 50 to 60 of them, it's a good idea to start using the input node in order to start controlling things, because the auto setup has additional information running through it that might not be needed, so you can speed things up if you're noticing a slowdown. That typically doesn't happen until you have several dozen of the nodes added in. Just because the calculations start to take a little bit longer when you're going between external dependencies. So we will go ahead and set up input node, MetaNode, and use time morpher in this way. Connect the top time input to time, and our pre-delay. We decided about 10 seconds into the animation we want to have the transition start. The transition is going to be the length and how many seconds it takes from between the targets, going between the current object and then the oncoming objects. So let's go ahead and set that transition to 3 for now, see how that's going to work out. And we need another external dependency, so we can add in external dependency. We could also use the recall dependency if we want to set up a delay. But we should be able to ease it in with the transition spline pretty good, and we won't have to use the delay, and that actually speeds things up, being able to modify things that way rather than using the dynamic controls. So input node, external dependency, and change it to the group position. And now we need to add in our combiner node, blender, making sure that it's set to blender. 0, input 0 is going to be our current dependency. So the FW190A3, and then the input 1 and our transition is going to go to that group position. So we want to clip ratio 0 to 1 for that ratio and connect it to the time morpher ratio output. And then take the vector and switch them over. So in 10 seconds, or after 10 seconds, we're going to transition to these other objects. And you can see the camera turn with it. And it eases in and out with that spline, which is pretty nice. So now if we want to have it switch back to the other object, back to the FW190A3, we can add another time morpher, and then just set up our delay, or the pre-delay amount, before the transition back is made. So we could set that up. We'll follow the objects up until maybe 13 seconds, 12 seconds or so, and then we can ease it back in. So what we're going to do is take the time morpher, we're going to copy and paste it in, connect the time to the time output of the previous time morph, and that way our pre-delay is offset by the total time in the previous morph, so 10 plus 3, so 13 seconds, is when this morph is going to start if the pre-delay is set to 0. So we basically have it bouncing back very quickly, so it transitions over. Because the objects are moving so quickly, once it finally lines up with the previous transition, it's already going to start going back. So if you want to add a few seconds to it, or I'm just going to go ahead and add 0.5, we're going to see how that works out. So that should be 13.5 seconds in, it'll do a 3-second transition. And we need to set up another blender. where we're going to have 0 be the current setup of the blender, and input 1, we're going to go back to the original object. So we're going to connect that to the external dependency, making sure that we clip that ratio 0 to 1. We are using the blend mode, which is really important for just switching back and forth between objects. We don't want to add or subtract or multiply. You can get some cool effects out of that, but in this case it's not something we want to do. So now we're going to connect the blender to the ratio output of the time morpher and take the connection to the track relationship from that blender down to the next level within the time morph chain. Click OK, and now we'll notice that transition back. So starting, the plane's moving and coming close to each other, they separate, our target changes, and then we go back. So if that's moving too quickly, moving back to the other target, what we can do is change the transition time, say 4 seconds. With the way the transition works, because we do have such a very large distance, that transition will happen very quickly, regardless of the amount of transition time we have. So there are a couple of things we can do to ease it in a little bit better. We could use the transition spline. We could add additional morphs. We could start the delay a little earlier, -1, and it should start to mix them ahead of time. So before the full transition is complete, we're already turning back, and we've got a nice mix, and it does take a little bit longer then.